Okay, here we're looking at combining barium chloride and potassium carbonate, both as aqueous solutions. So again, we want to begin by writing the formulas for each of these. Okay, now a good trick too is if you see that you're dealing with just ionic compounds, you can probably just go ahead and get by writing the ions involved, and then you can swap and drop wherever you need to. So I know barium chloride, I've got barium, which has a 2+ charge. This is in group 2. And chlorine, that forms an ion chloride, it's in group 17, so it's a 1-. You've got potassium carbonate, so K with a 1+ charge, it's in group 1. Carbonate, that 8 tells you definitely need to look back here. Okay, and you'll find that carbonate is going to be a CO, where is it on here? Did I give you, oh, there it is. I was like, it's all the way up at the top. I was like, what? Okay, yeah, carbonate is a CO3 with a 2- charge. I didn't even see it in here. I was like, surely I didn't mess that up. Okay, so CO3 with a 2- charge. Okay, you might come down here to the bottom to go ahead and write out your reactants. So you got BA. If you swap and drop, that's going to be Cl2. For this to happen, we're going to put it aqueous. We're going to react it with potassium carbonate. So if you swap and drop, you're going to get K2CO3. Okay. And to see what the products are, we need to swap cations and anions. So instead of these two being a pair, we're going to put these two together. And we're going to combine these two together now. So now we're going to have Ba with a 2+ and CO3 2-. If you swap and drop, that's 2 and 2, so they cancel, so you'll just get BaCO3. Okay. And then remember, you can't put Cl and K. Remember, your cation always goes first. So you've got K with a 1+, Cl with a 1-. Swap and drop, you get KCl. All right, and we need to leave room to write their phases, okay, or their states. All right. Now that we have our compounds, we can use our solubility rules to predict the states. All right. If we look at what we're dealing with, let me try to put it where it's all in view. So can you see everything? There you go. All right, so we're going to look for something that deals with either group 2 elements or with carbonates. Okay, well, that's about group 1s, that's about acetates and nitrates, blah, blah, blah. Group 17, that's not what we're dealing with. Sulfates, not what we're dealing with. Oh, here's carbonate, so let me read it. So except for those in Rule 1, so except for things with metals from group 1 or ammonia. Carbonates, hydroxides, oxides, sulfides, and phosphates are insoluble. So what this is saying is that carbonates are insoluble unless they're with a group 1 metal or with ammonium. Okay, well, this carbonate is with a group 2, so it will not be soluble. It will remain insoluble, which means that it will be a solid. All right, and then let's look at KCl. There's really 2 rules that help with KCl. K is a group 1, chlorine is a group 17. All right, so this is group 2. This is a carbonate. Okay, so we found carbonates to be the rule that helped us find the solid. Okay, so group 1, all common salts of group 1 metals are soluble. All right, well, that's a group 1, so this should be soluble. And we can also back it up by saying all binary compounds of group 17 elements, except for fluorine, with metals are soluble unless they're one of those weird guys. Okay, well, this is group 17 with a group 1. That is without a doubt going to be soluble, so it will be aqueous in its state. Okay, so what this is saying is we're going to put 2 solutions together, 2 things that look like liquids, okay, but they're not pure liquids. So we're going to put 2 solutions together, and somehow some solids will form. This could look like a powder, it could get clumpy, it might look milky. You know, there's a bunch of different ways that this could present. In our lab that we're going to do on Wednesday, Thursday, and maybe into Friday, we're going to do a bunch of kinds of reactions, and you'll get to see a few examples of double replacement reactions where you do form a precipitate. Okay, and remember, a precipitate means a solid formed in a double replacement reaction between two aqueous solutions. Sorry for the shorthand, but that helps me. All right.